All right, last one for this form. Again, we got to eliminate the same variable twice. So when I'm looking at my coefficients, it looks like the z's are going to be the easiest to eliminate. So let me start by putting, I'm going to work down here right now, equation 1 and equation 2 together. And I can see that in order to add these equations and totally eliminate z, I'm going to have to multiply that top equation by -2. All right, so here's what we would have. Just rewriting the equations right now, so we'll actually go through and do the multiplication here in a second. So when I multiply that top equation by -2, I'm going to get, so I'll have 6x minus 10y minus 4z equals positive 38. And then the bottom equation just stays as is. And then what's nice is that I have the same coefficient in front of z, one positive, one negative, so I can add those two equations together to eliminate z. And that's going to give me 11x minus 11y equals 33. And we'll call that equation 4. Then I'll do the same thing, sticking with eliminating z's, but this time I'm going to take equation 2 and equation 3. So equation 2 I don't need to do anything with, just going to rewrite it here. But then equation 3, just like I did in the previous step, I'm going to have to multiply it by -2 so that I end up with something that will allow me to eliminate my z's. So when I multiply that all out, so I've got equation 2 and equation 3. So top doesn't change. But then I'll have -8x plus 4y minus 4z equals -4. And then once again, since I have the same coefficient in front of z, one positive, one negative, I can just add these together. So I'll have -3x plus 3y equals -9. Okay, so let's put that's equation 5. Let's put equation 4 and equation 5 together. Now there's actually something really interesting here that I'm going to do with this. So equation 4, I have, 11x minus 11y equals 33, and -3x plus 3y equals -9. Now what I'm going to do, instead of multiplying the equations by something, because I'd have to multiply by 3 and 11 to get 33 in front of both either the x's or the y's, I'm actually going to divide. So what I'm going to do is I'm going to divide that entire equation by 11, and I'm going to divide this entire equation by 3. And part of the reason I'm doing that is that I noticed that we have a greatest common factor in both of those equations. So I can sort of reduce the equations a little bit, make them easier to work with. So that's going to leave me with x minus y equals 3, and -x plus y equals -3. Again, I can add these together since I have opposite signs in front of the x's. That's going to be 0. But wait, that's also 0. Okay, so the left side's 0. Oh my gosh, the right side's also 0. So if you remember earlier, what we said was in this situation, this does not mean there's no solutions because, guys, 0 is always going to be equal to 0, right? This is a true statement. So what this means is that there's actually an infinite number of solutions. We aren't going to worry about how we'll write those solutions, but it is an infinite number of solutions.